Hey there, I'm going to walk you through this table of soil attributes. It's a summary of these soil properties we looked at in the field and their importance. Let's start with horizon thickness. Horizon thickness shows the history of the landscape. This can be a good indicator of plant growth potential. For instance, a nice thick AH is an indicator of good growing medium for plants. Color provides clues about soil properties and condition. It's often used to distinguish soil horizons in the field. Dark colors are a good indicator of higher organic matter content, such as that nice AH horizon. Water content has an effect on color. So let's consider nice well-drained soils. You'll often find bright red and yellow colors, which will indicate the presence of iron and manganese oxides. So these iron and manganese oxides, there's oxygen present. They're aerobic conditions. In poorly drained soils, you have a reduced iron and manganese, so there is no oxygen present. What's generated are gray and blue colors. We call these glade colors. The other thing you'll often see are mottles. The nice red colors in the contrasting gray. Texture is a primary soil particle. It's a proportion of sand, silt, and clay in the soil. It influences soil structure and consistence in various ways. This isn't noted here, but soil texture is highly variable and can be a good indicator of parent geologic material. For instance, an aeolian deposit is high in silt, whereas a lacustrine deposit will have more silts and clays. Texture influences soil properties such as drainage, available soil moisture, which is related to porosity, which is also related to the water holding capacity of soil. Trafficability, in other words, can you operate machinery on it? Texture is also related to soil temperature relations, soil air, soil structure, and the nutrient availability. Recall that clay has much higher surface area than sand, therefore there are more sites for absorption of different nutrients onto clay. Texture is critical for understanding soil behavior and management. Structure is a secondary aggregation of these primary soil particles along with organic matter. We call these PEDs. For example, sandy soils with organic matter tend to have a granular structure. Clay, silts, soils with less organic matter will have a blocky structure. Extreme wetting and drying can result in prism structures, and urban soils often have a massive structure, so large, tightly bonded blocks of soil. Structure influences the same properties as texture, but truly its greatest effect is on porosity, in other words, soil moisture and air relations, more so than texture. We talked about macropores and micropores. Macropores are the pores between the PEDs, and these pores are where water and air exchange quite rapidly. When structure is damaged in the soil, for instance by compaction with machinery or tillage, it's impossible to recreate it in a short period of time. The structure takes a long time to develop. Let's talk about consistence. This is the soil strength. Remember the pinch test in the field? This is soil's ability to withstand crushing. Consistence decreases with increased soil moisture, so it's more crushable when wet. It's an important consideration when operating machinery or building roads. Roots are a good indicator of bulk density, compaction, and porosity. For instance, recall at the logger sports field how there was roots that weren't growing beyond an impenetrable layer. Roots can increase soil porosity, thereby decreasing soil bulk density. Roots help stabilize, hold together PEDs and soils and reduce erosion. They can be an indicator of site productivity, and indicators where water might accumulate. Percent coarse fragments. It really does not contribute to the soil's ability to support plants. Can be helpful for drainage. However, it does decrease because it does decrease the water holding capacity, and it does decrease nutrient retention, especially at high proportions. And similar to texture, it's a good indicator of parent material. Horizon boundaries show the history of the landscape and are used to help classify soils. For instance, in the video we watched last week, the AP horizon was a nice abrupt boundary because of the tillage in the past. Another example would be these cryosolic soils. I briefly talked about those in one presentation. They're found in permafrost areas. pH can indicate parent geologic material types. Granite, sandstone, shale are acidic. Limestone is alkaline. This is in the interior of the province. pH is influenced by vegetation, so more acidic with coniferous needles than in deciduous or grassland environments. And what's important to note is that pH influences nutrient availability, so different nutrients become mobile depending on the pH of the soil. That's it for now.